Why lithium, nickel, copper, and sulfur matter. The hidden EV battery boom no one saw coming. Summary statement. The global transition toward electric vehicles is creating demand not only for obvious battery materials such as lithium and nickel, but also for the hidden commodities and industrial processes that make those batteries possible. As vehicles become software-defined machines and nations race to electrify transportation, strategic materials such as copper and even overlooked inputs like sulfur are becoming increasingly critical. The result is a growing network of commodity bottlenecks, supply chain dependencies, and industrial repricing that extends far beyond the battery itself. Introduction: the sulfur surprise. In early June 2026, sulfur futures in China surged past 8,033 CNY per ton, a new all-time high. The price had already been climbing sharply for over a year, well before the full impact of Middle East disruptions. For most observers, this was unexpected. Sulfur was long viewed as a low-value fertilizer byproduct, not a strategic input for the 21st century economy. Yet here we are. Sulfur prices have decoupled from traditional agricultural cycles and entered a structural bull market. This is not an isolated anomaly. It is a symptom of something much larger: the hidden industrial foundations required to build the electric future. While the world fixates on lithium and nickel inside the battery, the real story lies in the full stack of materials and processes needed to produce them at scale. Vehicles are no longer just mechanical devices. They are becoming computers on wheels, programmable platforms with continuous software updates, autonomous capabilities, and data-driven optimization. This shift, accelerated by China's industrial scale, is driving a once-in-a-generation rollover of global infrastructure, energy systems, and manufacturing. The result is intense pressure on a handful of critical commodities, some obvious, some surprising, and the emergence of persistent bottlenecks that markets are only beginning to price in. Number 1. The world is upgrading its operating system. For the past 30 to 40 years, the global economy has been laying the groundwork for a profound technological and industrial transition. Internal combustion engines are giving way to electric powertrains. Fossil fuel dominance is yielding to widespread electrification. Manual and analog processes are being replaced by SLAM, synthetic labor and automated manpower, through robotics, AI, and intelligent systems. China has acted as the primary accelerator. Through massive investment, policy coordination, and sheer scale, it has become the manufacturing and processing hub for the new energy economy. This is not merely catching up. It is compressing decades of development into a short window, creating explosive demand for the physical inputs that underpin the upgrade. Electric vehicles sit at the center of this shift. They are not just cleaner cars. They are software-defined machines with far greater optionality than traditional ICE vehicles. Over-the-air updates, energy management algorithms, vehicle-to-grid integration, and future autonomous features give EVs a fundamentally different value proposition. This technological leap is driving sustained, compounding demand for the entire base of the supply chain. Number 2, the 4 critical materials. The EV battery supply chain rests on 4 foundational commodities, each playing a distinct role. Lithium. The storage metal lithium enables the electrochemical reaction that makes high-performance rechargeable batteries possible. China dominates refining and chemical processing, even as raw material comes from Australia, Chile, and elsewhere. Nickel. The range metal high nickel cathodes, NMC and NCA, deliver superior energy density, allowing longer driving ranges in lighter, more efficient battery packs. Nickel-rich chemistries remain essential for premium and long-range vehicles. Copper. The electrification metal. Copper is the backbone of motors, wiring, charging infrastructure, and power distribution. As the world electrifies everything from vehicles to data centers, copper demand is structurally elevated. Sulfur, the processing metal. This is the surprise element. Sulfur itself does not go into the final battery. Instead, enormous quantities are converted into sulfuric acid to process nickel ore into battery-grade material. This hidden role has turned sulfur into one of the most dramatic commodity stories of the energy transition. These materials do not operate in isolation. They form an interdependent chain where strength in one area can create bottlenecks in another. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. Number 3. The sulfur surprise. Historically, sulfur was a hitchhiker commodity, roughly 80% produced as a mandatory byproduct of oil refining and sour gas processing to meet clean fuel standards. Its price tracked fertilizer demand and remained relatively subdued. That changed with Indonesia's aggressive push into battery-grade nickel. Laterite nickel ores, abundant in Indonesia, require high-pressure acid leaching, HPAL, to become suitable for EV batteries. The process is extraordinarily acid-intensive. It takes approximately 10 to 12 tons of elemental sulfur, converted into sulfuric acid, to produce 1 ton of nickel in mixed hydroxide precipitate, MHP form. Starting in 2024 to 2025, Indonesia's HPAL plants created a new, voracious industrial consumer for sulfur. Spot prices in key markets surged more than 400% before geopolitical events in the Middle East added further pressure. Fertilizer producers suddenly found themselves bidding against battery refiners for limited volumes. Even as sulfur futures hit record highs near 8,000 CNY per ton, the market remained in a structural deficit. This was not a simple supply shock. It was a classic case of demand transformation meeting inelastic supply. Number 4. The ghost abundance trap. Canada sits on some of the world's largest above-ground sulfur stockpiles. Mountains of solid blocks from oil sands operations totaling nearly 10 million tons, yet prices still went parabolic. This is the ghost abundance trap in action. A commodity's price is not determined by how much exists on Earth, but by how much can be refined, transported, and delivered to a factory door today. Sulfur in Alberta is locked in solid blocks that must be excavated, melted, prilled, and railed to port, a process that costs roughly $150 or more per ton in logistics alone. Melting and prilling capacity is limited. When Indonesia's HPAL plants needed millions of tons immediately, the infrastructure could not respond fast enough. Theoretical abundance became irrelevant. The same logic applies to other hitchhiker commodities. Supply cannot scale instantly with price because production is tied to other primary processes. Number 5. Indonesia, the partial exception. In a world where China controls the majority of refining and processing for lithium, rare earths, cobalt, and graphite, Indonesia stands out as a rare success story. By imposing an ore export ban and attracting massive investment, Indonesia has built one of the few major non-China refining hubs for a Tier 1 battery metal at industrial scale. HPAL capacity has expanded rapidly, positioning Indonesia as a dominant supplier of battery-grade nickel intermediates. This move up the value chain has delivered jobs, revenue, and strategic leverage. However, the nuance matters. Chinese companies own or finance the majority of these HPAL plants. Indonesia has captured the physical processing, but the broader network effect, technology, capital, and downstream integration remains heavily China-linked. The refinery moved next door, but the control center did not fully relocate. Number 6. Broader implications. This pattern repeats across hitchhiker commodities. Cobalt rides nickel, silver and germanium ride zinc. Each new demand wave exposes fresh bottlenecks. The AI boom adds further pressure through data centers and semiconductors, compounding the strain on copper, silver, and specialized materials. The mad rush we are experiencing is the visible compression of multiple long-term transitions: energy, digitalization, automation, geopolitical repositioning. China's scale has accelerated the timeline, but the underlying forces are global. Conclusion. The inputs. Beneath the inputs. Electric vehicles are computers on wheels. Their success depends not just on what goes inside the battery, but on the entire hidden industrial stack required to produce them at scale. Lithium, nickel, copper, and sulfur represent different layers of that stack: storage, range, conductivity, processing. Their rising importance signals that the energy transition is entering a more material-intensive phase. The most critical commodities of the next decade may not be the glamorous ones inside the cell, but the unsexy enablers that make the cell possible. Markets are only beginning to digest this reality. The commodity bottlenecks and ghost abundance traps we are seeing today are not temporary glitches. They are features of a world upgrading its operating system at unprecedented speed. The mad rush is real, and it is still in its early innings.